Assalamualaikum. We meet again on lecture PHY260 for online learning due to COVID-19. So I will explain to you the next chapter, chapter 2, about the optical instrument. For your information, we have 5 subtopics that we will cover for this chapter. First one is the eye, the magnifying glass, cameras and projectors, compound microscope, and lastly is telescope. For the first one, we are going to cover the first subtopic, which is the eye and the corrective lenses. As you can see in this slide, this is the schematic diagram of human eye. Human eye is the most fascinating optical instrument given by our God. So from here, you can see there are important parts, some of the important parts in the eye, in human eye. Okay, the first one we can see, we have here cornea. Okay, cornea will act as made up from a spherical membrane. Okay, and then it allowed light to enter our eye. And then we have pupil of the cornea. Pupil is known as the hole in the middle of the iris. It allowed light to enter the eye. And then we have iris. Iris will control the amount of the light enter the eye, okay, by adjusting the lens. And we have lens here to focus the object we see. And then we have retina, is the back of our eye, which is where images are focused. And we have optic nerve, which is this nerve bring the information from the retina to our brain and translated it into whatever we see. The characteristics of human eye, we have field of view for both eye at 130 degree in diameter, and the pupil diameter range from 2 mm to 8 mm according to the conditions or according to the light entering towards our eye. So this is the link for you, or you can see this video in YouTube. It will give you a really simple and a really simple explanation about human eye. Okay, so without further ado, let us see the video.
Kids Health presents How the Body Works with Chloe and the Nerve.
Nerve, just because eyeballs are the size of ping pong balls doesn't mean they make good ping pong balls.
A Nerve cannot be blamed for his love of scientific exploration, my dear Chloe. It is what makes him a Nerve.
Then can we use the eyeballs to explore how an eyeball works instead?
We could, but these are kind of small and
Squished.
one might say that.
How about we take a look at him?
Most excellent idea. Let's do. The eyeball is a beautiful machine with lots of different parts working together to let you see.
Poets say the eyes are the window to the soul.
Well, the window to the eyeball is the cornea, a dome of clear tissue up in front of the eye that focuses light as it passes through. Look at that beautiful green eye, and brown eye, and blue eye.
The colorful part is called the iris, right?
Yep, it's right behind the cornea. In the middle of the iris is a black circle called the pupil, an opening that lets light into the eye. The iris has muscles attached to it that change its size, making the pupil bigger and smaller to control how much light gets through.
So the pupil gets smaller when there's a lot of light and bigger when it's dimmer. Don't look now, but I think we're being watched.
Ha! He blinked first.
Which is a good thing. blinking protects and moistens the eye.
Good point.
So what happens after the light has passed through the cornea and the pupil?
The light passes through the lens.
Like the lens in a camera?
Precisely. The lens focuses the light onto the back of the eye, where seeing really starts to happen.
Can the lens in the eye focus on stuff that's close and stuff that's far, like a camera lens would?
It sure can. Let's head inside to see how. Last one through the pupil's a rotten egg. The lens is held in place by a bunch of fibers which are attached to the ciliary muscle.
Ciliary.
The ciliary muscles change the shape of the lens to let the eye change its focus from something close by to something far away.
What are you waiting for? Let's get focusing!
To see something near, the ciliary muscle makes the lens thicker. To see something far, the ciliary muscle makes the lens thinner. From the lens, we travel to the retina, the back wall of the eyeball.
Right, because the lens focuses the light onto the retina.
The retina has millions of light-sensitive cells called rods and cones. About 120 million rods and 7 million cones in each eye.
Whoa, that's a lot of rods and cones. What's the difference between them?
It's the difference between black and white and color. The rods see in black, white, and shades of gray and help us see the shape and form of a thing. Rods also help us see in the dark.
And the cones see color?
Cones are sensitive to one of 3 colors, red, green, or blue. Together they let us see millions of colors. But cones need more light than rods to work well.
Hey, what's this thing behind the retina?
Hey, no bouncing on the optic nerve. It carries messages to the brain about what you're seeing. The rods and cones change the colors and shapes you see into millions of nerve messages. Then, those messages are carried along the optic nerve to the brain.
It's like your eye is sending the brain a report on what you're seeing.
Then your brain translates the report into cat, apple, or bicycle.
Or a ping pong ball. Keep your eye on the ball there, Nerb.
No, it's on.
Fascinating, right? This is one of the videos that I found very interesting for you to look at. So the focusing adjustment is called accommodation for the eye. This is due to the lens. Okay, the lens will be adjusted due to the distance of the object. You see, so we have 2 points that you need to know, which is the near point, known as the closest distance. Eye can focus clearly. Normal and healthy eye at 25 cm, and far point is the farthest distance which object can be seen clearly. Normal eye at infinity. So you can see here the accommodation made by normal eye. The next one is the eye problem or the defects. So first one is myopia or nearsightedness, or in bahasa call it as rabun jauh. This is happen because too much power in cornea and lens and cause the eyeball become too long. Okay, so when the eyeball become too long, the image form is formed in front of the retina. So to correct this problem, we are going to use a diverging lens. The second one is hyperopia or farsightedness. Farsightedness in bahasa called as rabun dekat. Okay, this is due to too little power in the cornea and lens, and it causes the eyeball become too short. So the near point is far than normal eye, which is 25 cm. So when it focuses, the image form are formed at the back of the retina. So to correct this problem, we are going to use the converging lens or the positive power. So this is presbyopia, or known as Adderley visions. This is due to the edging effect. This is due to the lens become hardened and it become difficult to squeeze, and it will disturb the focusing adjustment in normal eye. So it require two type of lens, which is converging and diverging lens. So this is example of the eyeglass or the spectacles that presbyopia patient will use. It have near using the converging lens, and it have far lens using the diverging lens. So this is the equation for the optometrist to determine the power of lenses of their patient. Okay, P is equal to 1 over focal length. But remember, focal length must be converted into meters. And the unit is diopter. So, let us try the exercise 2.1. Sue is far-sighted with a near point of 100 cm. Reading glasses must have power. What power does reading glasses must have? So, she can read a newspaper at distance of 25 cm. Okay, assume the lens is very close to the eye. So, from the question, what can I take out is, I know the image distance is equal to minus 100 cm. The object distance is equal to 25 cm. And we are going to find the power. Since we have these two information, we can use lens equation to get the focal length. So 1 over f is equal to 1 over u plus 1 over v. Substitute all the value. So you get the focal length is 33.3 centimeter. Since power equation is equal to 1 over f, so it's equal to 1 over 0.33 meter. Remember, focal length must be in meter if you want to find the power. So, the final answer is positive 3 diopter. So, positive here representing that it will use a converging lens due to the far-sighted problem. So, as you can see from your slide, there are more exercises about this equation. So, all the answer given in this slide is correct because I already done it by myself. Okay, so you can try on your own. If you have any problem, feel free to inform me. I will show you the calculation later. So, end of the first session. I will see you on the next subtopic, which is the magnifying glass. Stay tuned and stay safe. Thank you.